Now let's look at some examples using our supplementary, complementary, and vertical angles. So any line that intersects a pair of lines is a transversal line. So let me come through here, and I have line N, and I have line M, and I cut those lines by line P. So line P is a transversal line. Now those can be parallel lines, M and M. They don't have to be. And then angles are formed, okay, and they're named accordingly to their placement. And different ones name them differently. We're going to name them 1, 2, 3, 4, 5, 6, 7, and 8 just for our sake. And that way we can look at these as we go, okay? Because there's a few things that we want to look at. We want to look at something called interior angles. Interior angles are those that are in between the two lines that got cut. So interior angles would include the 5, 6, 2, and 4. So interior angles would be 5, 6, 2, and 4 in our case. Exterior angles are those on the outside of the lines that are cut by the transversal. So that would include 3, 1, 7, and 8. In other words, on the outside. Think about these are lanes on a highway or something, and you're on the outside, okay? That's what the exterior angles are. Alternate interior angles. These are, well, they have to be these angles right here that we're looking at, 5, 6, 2, and 4, so 5, 6, 2, and 4. Alternate interior angles are those that are on opposite sides on opposite lines. So not right next to each other, they can't be adjacent in any form. So 4 and 5 are adjacent, 5 and 6 are adjacent, so 5 and 2 are alternate interior angles. 6 and 4, they cross over that transversal line. So 4 and 6 are alternate interior angles. Alternate exterior angles, oh, let me go back up, sorry. Alternate exterior are the same way. They cross over the transversal line. So 3 and 8, 7 and 1. So 3, 8, 7, and 1. Corresponding angles are those that are basically in the same place. If you look at where they are in relation to the two lines that were cut by the transversal. So notice where 1 is on line N. On line M, it's in the upper right corner. On line M, 2 is in the upper right corner. So 1 and 2 are corresponding angles. 6 and 8 are in the lower right, So they would be corresponding angles. 3 and 4, 5 and 7 would be corresponding angles. And so I basically filled out this table just on the other page so that we could see it a little bit easier. Now this theorem says if any two distinct coplanar lines are cut by a transversal, then a pair of corresponding angles, alternate interior or alternate exterior angles, are congruent if and only if the lines are parallel. So line N and line M must be parallel for angles 1 and 2 to be corresponding. Not to be corresponding, but to be congruent. Okay? If they're not parallel, then these are not going to be congruent. And that's what this theorem is stating. So I'm going to attempt, and I do say attempt, to draw. Not too bad. There's line N, and there's line M, and I'm going to cut it with line P. There's line P. Okay. And I'm going to label that here's angle 1 and here's angle 2. So based on what I just said, there's a few things that we know. So let's think about this. Based on what the previous theorem just told us, corresponding angles, alternate interior angles, and alternate exterior angles, those are going to be congruent if these lines are parallel. So this is going to be congruent with this angle because they are corresponding angles, provided that M and N are parallel. So if these two angles are parallel and angle 2 is over here, what did supplementary angles have to add up to? Well, supplementary angles have to add up, not to 360, they have to add up to 180 degrees, a straight line. Well, this is a straight line. Here's one angle, here's two angles. So basically, if I think about this, right here, angle 2 and this angle over here, so this angle and this angle are supplementary to each other. So what I need to do is I need to say that this angle and this angle and angle 1 are congruent. Well, based on the theorem that we just stated, corresponding angles are congruent. So if this is actually equal to angle 1, then this angle is supplementary to this angle. So angle 2 and angle 1 are supplementary because angle 2 is congruent to the angle next to angle 1, or vice versa. Now, are the following lines parallel? Okay. If these lines are parallel, that's a big if. If these lines are parallel, alternate interior angles would be congruent. So that would mean that this would be 50 degrees. Now, if this is 50 degrees, this forms a straight line, so this is supplementary. So that would mean this is 180 minus 50. So this is 130 degrees because this is supplementary. Okay. Now, let's think about this. Let me go with this color. These two angles here are supplementary. So since they are supplementary, that would mean that this angle is going to be 180 minus 70, which would give me 110 degrees. Now, based on transversal, this angle and this angle would be congruent, so that would be 70 degrees. Now, straight line here, if these are parallel, hopefully 70, 60, and 50 would add up to 180. Let's see. 70 and 60 is 130 plus 150. Yeah. These three right here, 70 plus 60 plus 50, that equals 180 degrees. So based on what we're told, these two alternate interior angles are congruent. These two alternate interior angles are congruent. Therefore, these lines must be parallel.